Hi class, this is lesson 5.4b, Applications to Solving Compound Inequalities. The objective for today is to be able to set up and solve real-world problems by using compound inequalities. Before we get into applications, let's first start by reviewing how to solve a compound inequality. So below I have an inequality listed. We have 10m minus 7 is less than 17m, or negative 6m is greater than 36. So I'm going to start by identifying this as a union. So I'm going to solve these two inequalities as separate inequalities, and I should get two values as my answer. So I'm going to start by getting the variables to one side. So I'm going to subtract over the 17m. On this side, I'm going to start by getting the m by itself by dividing by negative 6. (10 minus 17m is a negative, don't drop your negative off, 7m, minus 7 less than 0. Over here, I divided by a negative, so I have to make sure to flip that sign. 36 divided by negative 6 is negative 6, and once again, I flipped my sign because of this step right here. Over here, I need to still get m by itself, so I'm going to add over the 7. And then I'm going to divide by this negative 7. Once again, I divided by negative 7, so I have to flip my sign. So remember, we always need to graph inequalities to represent the solution set. So I'm going to start by plotting negative 1 and negative 6. Remember, negative 6 is smaller than negative 1, so it should go to the left of the negative 1. Both of my inequality signs do not have equal signs, so I'm going to use an open circle. For m less than negative 6, I need to shade to the left. And for m greater than negative 1, I need to shade to the right. To check my solution, I'm going to pick something in that shaded region, which just so happens 0 is in that shaded region. And I'm going to replace m with 0, just as I have done here, and then simplify down. So I have negative 7 less than 0, or 0 greater than 36. Now remember, for your unions, you have your two statements. At least one of the statements must be true for the inequality to be true. Negative 7 less than 0 is a true statement. 0 greater than 36 is a false statement. So as long as one of the statements is true, which is the case, our inequality is true. So let's first dive into writing compound inequalities. Our first problem talks about snakes. It says most snakes live where the temperature range from 75 degrees Fahrenheit to 90 degrees Fahrenheit, inclusive, meaning that 75 and 90 degrees can be included in the value. Write an inequality for temperatures where snakes will not thrive. So we're trying to figure out which temperatures would cause snakes to not be able to thrive, not be able to live. So let's think about this. We first need to figure out, okay, well, which temperatures would be too low for them to survive, and then which temperatures would be too hot for them to survive. Well, anything that is lower than 75 is going to cause snakes to struggle to thrive, and anything higher than 90 degrees is going to cause issues with them thriving in their environment. So those are our two constraints. So now let's write an inequality based on the information above. Let's let x equal the temperature, because we're talking about writing an inequality. Just like when you write equations, equations have variables, your inequalities will have a variable as well. Now, remember we said that the snakes will not thrive in a temperature that is lower than 75 or higher than 90. So if x is greater than 90, the snakes are not going to thrive. If x is less than 75, they're not going to survive. So these are your restrictions. Atlantic sea turtles turtle eggs that incubate below 23 degrees Celsius or above 33 degrees Celsius rarely hatch. Write the temperature requirements as a compound inequality. So we're trying to figure out the requirements needed for these sea turtle eggs to incubate in order for them to hatch. So we need to figure out, well, what does the temperature need to be for them to hatch? Well, it needs to be at least above 23, but below 33. So let's start by letting x equal the temperature. Once again, the temperature has to be above 23 degrees, but lower than 33 degrees. So as long as x is less than 33 and greater than 23, they will hatch. So that is our inequality. So let's practice more writing. So next directions say define a variable, then write and solve an inequality. Check your solution. 8 less than a number is no more than 14 and no less than 5. Find the range of possible numbers. So the first thing you want to do is define a variable. We're supposed to be finding a possible number. So I'm going to let x equal a number. Next, we want to set up an inequality. So let's start by breaking apart this sentence. 8 less than a number. So 8 less than a number can be translated as x minus 8. Now we're talking about inequalities. So the next part of the statement says 8 less than a number is no more than 14. So that means it can be 14 or anything smaller than it, but it can't be bigger than 14. It can be no more than 14. So that statement represents a less than or equal to sign. The next statement says, and it cannot be less than 5, no less than 5. So that means it can be 5 or anything bigger than 5, but it can't go smaller than 5. So it has to be greater than or equal to. So that is our inequality. So this difference here must be greater than or equal to 5, but less than or equal to 14. So that's our compound inequality. The next step is to solve. So I'm going to start by looking at the middle of my inequality and get stuff away from x. The first thing I need to do is add over my 8. I get 13 is less than or equal to x, which is less than or equal to 22. So at that point, the inequality is solved. So I was supposed to be finding a range of possible numbers. Well, the number can be anything less than or equal to 22 or anything greater than or equal to 13. So your possible numbers will lie between 13 and 22. The sum of 3 times a number and 4 is between -8 and 10. Find the range of possible numbers. So once again, the first thing we want to do is define a variable. We're looking for a possible number. I'm going to let x equal a number. Next is write an inequality. So I'm going to start breaking apart my sentence. The sum of 3 times a number and 4. So the sum, addition, 3 times a number, 3x, and 4. Is between. So remember, between means intersection. So they have to fall between those two values. You should be picturing that number line with the overlap shading as your answer. So it has to be between 10 and -8. Now the placement of these numbers does matter. We want it to be greater than or equal to -8 because -8 is the smaller value. But it has to be less than or equal to 10. For it to fall between there, it has to be smaller than 10, bigger than -8 to fall in that intersection. So now we just need to solve. So I'm going to focus on the middle part of my inequality and start by subtracting 4 to the. So subtracting -4, I get -12 less than or equal to 3x less than 6. Next I need to divide the middle left and right by 3. I did not divide by a negative, so I don't need to flip my sign. Negative 12 divided by 3 is negative 4. 6 divided by 3 is 2. So I was trying to find the range of possible numbers. Well, the range of possible numbers will be between 2 and negative 4. So the number will have to be smaller than 2, but bigger than negative 4. So the number lies between 2 and negative 4. Here's one for you to try on your own. It talks about the product of negative 5 and a number is greater than 35 or less than 10. Find the range of possible numbers. Take a second to pause the video and try this problem on your own. The first thing you want to do is to find a variable. Like we did in the previous problems, we're looking for a range of numbers, so I'm going to let x equal a number. Then I'm going to write my inequality. Now this one's a little bit tricky. It says the product of negative 5 and a number. Well, product means multiply. A number is x, so negative 5 times x is greater than 35. Greater than 35. Or, that or is going to be the or we use to represent a union. Or is saying the same product, so negative 5x, is less than 10. So that is your setup. And then from there, when you go to solve, you're just going to divide by negative 5. Make sure you flip your inequality sign. 35 divided by negative 5 is negative 7. 10 divided by negative 5 is negative 2. Once again, flip that inequality sign. So to really understand this problem, it might be helpful to graph. So I went ahead and placed it on a graph. Here's what your solutions tell you. So when we talk about the range of possible numbers, they're going to be any number except the numbers that fall between negative 2 and negative 7, because notice that's not a shaded region. So anything that is bigger than negative 2 and anything that's less than negative 7 will satisfy the range of numbers, but the numbers between negative 2 and negative 7 will not satisfy those numbers. The triangle inequality theorem states that the sum of the measures of any two sides of a triangle is greater than the measure of the third side of the triangle. And the triangle is pictured here. Write and solve 3 inequalities to express the relationships among the measures of the sides of the triangle shown at the right. So, possible relationships, I'm going to have 3 of them. My first possibility would be if I took my side x, added it to my side 9. These two sides would have to be greater than 4 when I add them together. So x plus 9 equals 4. When I solve, I get x is greater than negative 5. My second possible relationship would be side x plus side 4 is greater than 9. When I solve, I get x greater than 5. My last possible relationship would be side 9 plus side 4 greater than side x. So 9 plus 4 greater than x. Now when I go to solve that, 9 plus 4 is 13. I'm going to write my answer with the variable on the left. So notice that here the inequality sign is pointed towards the x. When I wrote it, inequality sign is still pointed towards the x. So I haven't changed the value of anything, I just wrote it in the format that most students are used to working with. Now remember, we're talking about a triangle here, and these values are supposed to represent length. And usually length is not negative. We don't usually say that a side of a triangle is negative 5 inches. So we're going to rule out that first possible relationship just because it's not practical for the situation we're working with. So part B says, what are 4 possible lengths for the third side of the triangle? Well, here's our possible relationships. Remember, we ruled out possibility 1 because it was negative. So we're looking at 2 and 3. So if x is greater than 5, so any number greater than 5 would work, but it also has to be less than 13. So some values that fall between 5 and 13, we could say 6, 8, 9, 11. other possibilities as well. Those are not the only possibilities, but they would need to fall between 5 and 13. That's the key there. Greater than 5, but less than 13. Part C. Write a compound inequality for the possible values of x. Well, as we said before, here's some of the possible answers. Remember, we ruled out number 1 because it's negative. So to write a compound inequality, just as we said before, x has to be bigger than 5 but less than 13. So x would fall between 5 and 13. The length of that third side would have to be between 5 and 13. Okay? So did you meet the objective? One last problem for you guys to try out. See if you can set it up. Your answer should be that the number is between 0 and 2. If you are struggling with this lesson or have any additional questions, please do not hesitate to come see me. Make arrangements with me before or after school to get additional help.